No, I'm not telling him about the movie. All right, guys. Charles, everyone says hi. Okay. Hey. Guys. Okay. Our objective today is to review for the Chapter 8 test. On Monday, we're going to take the Chapter 8 test. You should really not have much homework this weekend. I am going to give you guys class time today to work on the review. That way, if you have questions for me, we can take care of those today during class. So I want to start with going over the warm-up. You guys had 4 graphing inequality problems I had up here that you had to graph on the graph paper on your desk. So we're going to start with those. Okay. Number 1, the y equals form, Doug, should be what? Y is less than, you mean, right? 5 over 4x minus? Okay, 10 over 4 reduces to 5 over 2, which is 2.5. So I would change that to a decimal so it's easier to graph. But why didn't you say that? Oh, gotcha. On the graph, you had your decimal. Okay. Emma H., where do we start with graphing? Good. So down 2.5. Jeremy, after we start at 2.5, what do we do? Well, just tell. I want you to focus on this with us right now. After you start here, what do you do? Good. Up 5 over 4. Up 5 over 4. Adam, dash your solid line. Mentos. Good. Dashed line. Okay, Matt, where are we coloring? Good. Why? Good. It's less than. Less than means color below. So you're coloring underneath the graph. Also, look at the y-axis. Wherever the smaller numbers are, that's where you're coloring. Okay, or just look at the line. Wherever below is, that's where you're shading. Sean, give me one ordered pair that is a solution. There's millions of them. Just give us one. No. That's not going to be a solution. No. Negative 8 million to be way over here. You're not. You're not. You're just not thinking. Sean, there's millions of points. Give me one. Pick one in here.
Oh, in there. Oh.
Were you here yesterday? All right, let's go, Sean. Give me an ordered pair that's a solution. There we go. 8 million, negative pi. Justin. Good. 7 and negative 7 is a solution. Mary. Good. Pi, negative pi. Okay, Doug. No. That's not going to be a solution. Negative a trillion. Okay. Okay. Good. Okay. One more. Emma. There we go. All right, number 2. Alyssa, can you tell us the y equals form? Doug. Good job. Okay, so Zach, when we graph this, where do we start? Good. Start at 3. Briar, then what? Down 3 over 2. Down 3, whoops, down 3 over 2. Okay, it's greater than or equal to, so do not is dash or solid line. Good, solid line. Annalise, where do we color? Good. Top right, because it's greater than. Quiet. It's greater than or equal to. Okay, so top right. Emma H., give me one ordered pair that is a solution to this inequality. Good, pi pi. Mary, give me another ordered pair that's a solution to number 2. Good, 4, 2.5. So anything in the shaded region is a solution. Okay, number 3. Okay, the y equals of number 3 should be y less than negative 3x plus 6. Your inequality should look like the one I have up here. Number 4. Let's see. Alyssa, what's your y equals form? Good job. Y is greater than or equal to 3/4 x minus 3. Emma. Okay, but when you divide by a negative, you have to flip the inequality sign.
Oh, wait.
Okay. If you multiply or divide by a negative, make sure you flip that inequality sign. All right, any other questions on the warm-up? Annalise? Yeah. I mean, if I took more time, I would use a highlighter, but you guys get the point, right? Scribble. Okay, let's go to practice 8.9 first. Okay. Okay, practice 8.9 solutions. Number 1. Who can tell us what's wrong with number 1? Matt. Right. So they should have started at 3, went down 5 to the right 6, down 5 to the right 6. They completely messed that up. So they graphed it wrong. Okay, Mary? Yeah, that's fine. Number 2, what's the problem, Donatus? Good. Number 2 should be a dashed line. So if you do that on Monday's test, I will take off half a point. Okay, it should be a dashed line. Annalise? Yeah, it was. Number 2, you mean? Start at 0, you go down 4 to the right 1. Down 4 to the right 1. You tell me why you don't start at -4. What's the y-intercept? Y is greater than -4x plus 0. There's not a number there. Since there's not a y-intercept, you start at 0. Your slope is -4, not the y-intercept.
Wait, but I thought the y-intercept was -4 because 0.
Yeah, you tell me. If you plug 0 in for x, what's -4 times 0? 0. Okay? All right, number 3 is yes, 4 is yes, 5 is yes, 6 is no. Okay, number 7. It's kind of hard to see all these. Let me shut these lights off for a couple minutes. Okay, number 7 should be a dashed line, color below. The y equals part of 7 is y is less than -3/4 x plus 9. Number 8, the y equals part is y is less than -7/4 x minus 8. Dashed line, color below. Number 9, y is less than or equal to 3/10 x minus 5. Solid line, color below. Number 10 should be y is greater than or equal to -2x plus 21. Solid line, color above. So again, all my graphs are up here. Number 11, y is greater than or equal to 4/9 x plus 2. Solid line, color above. Number 12, y is less than -1/2 x minus 11/2, which is minus 5.5. Dashed line, color below. Am I going too fast for anyone? Okay, making sure. Number 13 is what it is. Dashed line, color above. 14 is a solid line, color to the right. 15, I messed up on the top here, ignore that. 15 is a solid line, color below. Annalise. No, number 13 is a horizontal line. You go on the y-axis at -1, and the line goes across. Doug? Let me finish going over the answers. Okay. All right, number 16. So some of you guys kind of forgot how to set this up. Can someone tell us what the equation should be? Alyssa, go ahead. Good. 3x plus 1.5y less than or equal to 42. How would you graph that? There's 2 things you could do here. Mary, how would you graph that? Uh-huh. Good. So if you get it into y equals form, you end up with y is less than or equal to -2x plus 28. That's one way to graph it. That's the way I prefer. You also could have found the x and y intercept of this inequality if you wanted to, and then just plot them like that. So they ask you for C. Give 3 possible combinations of adult and child tickets that you can buy. All they're asking you is give 3 ordered pairs that fall in the colored region. So Emma, give us one.
0, 0.
Good, 0, 0. Yes. What's another one? I had to think about that for a second because it sounds weird. Donatus, what's another one? Yep, 14, 0 works. What's another one? Briar. No, that would be up here. You want it to be in the colored region. Okay, I'm just going to show you guys. I have a bunch of them listed, okay? There's a ton of them. So I at least wrote the ones that I have. Your solutions are going to be in that colored region, okay? There's a lot. I would say that there's infinite again. Annalise? 4, 22, yes. And 0 what? Perfect, because the line is solid. Yes. Emma? Yes. Mary? That works. As long as it's on the line or in the colored region, yes. All right, so that was 16. 17, same idea. Your equation should be 12x plus 4y greater than or equal to 136. Same kind of setup. And then if you put it into y equals form to graph, you should have y is greater than or equal to negative 3x plus 34. And then you're coloring above. They don't ask you for ordered pairs on this one, but there's a bunch of them you could put. Or do they? Wait, describing the box? No, they don't ask you. Alyssa. Did you put it into y equals form? It might have been me too. I sometimes do the answer key too quickly. As long as is it close, Alyssa? Or okay. As long as it's close, don't worry about it. I don't like this graph very much because it's scaled very weird, so it does get a little bit annoying. Yeah, it's annoying. So as long as you're close, you're fine. Okay. I like you guys pass this around. You leave it here sometimes too. Briar, special delivery. So Alyssa, yeah, as long as it's close, I will not take off points on that. Anyone else on that one, on 17? What'd you think about 18, 19, 20? I was wondering how you guys are doing this. Okay, 18, x is greater than or equal to negative 3. 19, y is less than negative 2. 20, y is less than x plus 2. Jeremy. But the slope is not 2 over 1. 2 over 1 would mean you go up 2 over 1. Up 2 over 1. That's not the slope. The slope is up 1 over 1. Up 1 over 1. Okay? You said 2 over 1, though. If you have 2 over 2, that's the same thing. Okay. Gotcha. 2 over 2 would have worked. Okay, before we go to 8, Doug, what number did you need me to go over? 11. Getting it into slope-intercept form or graphing it? Which to slope-intercept form? What? Okay, so 11 is 9y minus 4x greater than or equal to 18. Doug, what's the first thing you should do? So we have 9y greater than or equal to 4x plus 18. Then how do you get rid of the 9? Okay, so this is pretty much your answer. You get y greater than or equal to 4/9 x plus 2. Backwards? You mean it's 81? Okay. Try not to do that. Annalise. Okay, 11. You should have started at 2, which is right here. and then gone up 4, 1, 2, 3, 4, over 9. It's just going to be off the graph a little bit. Up 4 over 9 is right there. If you do the opposite point, 1, 2, 3, 4, down 4 over 9 is somewhere over there. I'm not a big fan of these graphs because the book does not take the time to think through how many points you guys need, and just sometimes kind of ends up off the graph. Gets on my nerves, but that's okay. You could still do it. It's just not nice. Oh, that's why. Okay. Yeah, how to graph it? Is that the, okay. So number 8, you said 8 or 9? 9, sorry. I don't know why I was looking at 8. Okay, number 9, you should have y is less than or equal to 3/10 x minus 5. So start at -5. Okay, that's why. You probably just divided wrong. -50 divided by 10 is -5. Well, it's positive 3/10. Your slope-intercept form must have been wrong. Is that the problem? No, okay. We got to go backwards. Annalise, how do you get -3x to the other side? You add it. That's where you messed up. So it wasn't your graph, it was your slope-intercept form. So you add 3x to both sides, so you have 10y less than or equal to 3x minus 50, then divide everything by 10. So you get positive 3/10 x minus 5. So that's why, you're welcome, that's why your graph was a little bit wrong. Anyone else on 8-8 before we go, or anything else on 8-9 before we go back to 8-8? All right. You guys felt like that was pretty easy, right? Okay. Let's go to, you guys had a couple problems on 8.8, starting with 11. Okay, Sean, what did you get for number 11 on 8.8? Good. Why is there no solution? Good. No solution because they're parallel lines. Matt, number 12. Yeah, not right. If all else fails, check them on your calculator. Alyssa, what did you get? Close. Annalise? 2 comma -1. Did you just forget to put the negative, Alyssa? Okay. Over 2 down 1 is where they cross. 13, Adam, what is the equation for 13a? Or equations, I should say. Good. Perfect. Emma H., what did you put for part B? 45 family members? Good. And Justin, what about C? So there were kind of 2 questions there, Justin. The first part. Okay. Okay, good. So the first question was, when does the first option have the lower total cost? It's when there's less than 45 family members that attend. Second question, when does the second option have the lower cost? When more than 45 family members attend. Annalise.
I got those wrong because I thought that for the second one, or for the first one, y would be 840 because I thought they said for the second option.
Oh yeah, they should have been more clear on that. They just meant that it's one fee, a flat fee of $600. I could see how you interpreted that. Yeah, you got one piece of advice. The book problems are typically easier than you think. They're a little bit more, they don't put as much, not as much thinking involved in some of them. So just 600 for that second equation. I am not going to write all of C since we kind of talked through that. 14 I told you not to do, right?
No, you said you.
Oh, I did tell you to do 14. Okay, 14. What did we get? I thought I told you to skip that. Briar, what did you get? Nope, you're close though. Matt? Close. Emma H? Good. Emma H, how'd you get that? Listen. Say that again. Take your time. You might have graphed it. You did not? Okay. I'm just curious how you got it. Okay. Okay, you can do it that way. Doug, how did you get 14? Did you get it right? Okay. Annalise, did you get 14 right? Okay, hold on. Anyone else get it right? You want to try to explain what you did before I explain it? Mary? Ooh, very good. Perfect. And then what did you do after that? Okay. You got 5.5 hours though, correct? Good job. That works. Donatus, what did you do? Okay. Okay, so kind of like Mary, but you graphed them. Okay. So, okay, I'll explain. So 14, Yep. Mm-hmm. Okay, that works. That's okay. Whatever you thought through, it's right. So 14, real quick, you won't have to know this formula for the test, but they use the formula distance equals rate times time. You guys ever heard of that? Distance equals rate times time. So one of the equations is distance equals 65 times t. I'm just using y and x. The other equation is distance equals 55, and then the time is t plus 1, because this one starts 1 hour ahead. So I put in here the t plus 1, which really could just be x plus 1. If you use t instead, that's fine. Now, those are the two equations. If you graph them and find the intersection point, you'll get that the x value is 5.5 hours. This is just like Mary's equation, but she did it backwards, which is the exact same thing, because there's 2 or 3 different ways to interpret this. Okay, you will not have one like this on the test, but makes you think a little bit. Annalise? Graph it. Graph it. You would distribute the 55 through. So you'd have 55x plus 55. So you would graph y equals 55x plus 55, graph y equals 65x, and you would find the intersection point, which gives you that it's 5.5 hours for x. So, interesting problem. Okay, 15 was also an interesting problem. You should have put all of those into y equals form and then found the vertices. So Matt, what are the vertices that you got? Very good. So again, if you put each of those into y equals form, which is slope-intercept form, graph them on graph paper or in your calculator, and find where they all cross, which is there's 3 vertices of the triangle, then the ordered pairs end up being the vertex of each one. So that problem wasn't bad once you realized that it had to be in slope-intercept form. Yes, Annalise?
I got 1, -3, and 3, 1 right, but I didn't get 1, -5. I got -2, 6.
Okay, then you probably counted wrong. Did you use graph paper or did you use your calculator? Okay, well maybe you counted wrong, but let me read through the slope-intercept forms you should have. Maybe your equations were wrong. So Annalise, for the first equation, it should be y equals -4x plus 1. That's why. It should have been -4x plus 1. So that messed you up. Anyone else? Mary? Uh-huh. You can get the other two. You mean for 15? You can use the trace button, and it'll get you to the other 2. Anyone else? Give me a thumbs up, thumbs middle, thumbs down on those homework assignments. Okay, good. All right, so I need you. Mary, is that a question? Go ahead. I'll come over and show you. Annalise? Okay, here's the other. Let me read all 3 slope-intercept form equations. Okay, so the first one, y equals -4x plus 1. Second one, y equals 2x minus 5. Third one, y equals negative x plus 4. Okay, here, look at my graph. You're probably just graphing them wrong. Okay, I need you guys to open up your book. 2 assignments. Let me just move this up here. Open up your book 446 first. Okay. So 446, don't start yet because I want to explain it. Okay. So 446, I need to give you guys graph paper. Okay? Don't start yet. I want each of you guys to take 2 pieces of graph paper. What are you talking about? Oh, you don't need to graph 3 and 4. That's why the graph paper's up there like that. Mary, I'll come help you. Don't worry about that yet. I just want to explain. Everyone take 2 of these. I gave enough so you each could have 2. You get it? You sure? Think or you did?
Well, yeah.
Okay. Okay. I mean, no. I'm just kidding. All right, guys. So your graph paper. Okay, first thing I want you to do is put your name at the top of the graph paper. You should each have 2 pages. Sean, you with me? Okay. You should each have 2 pages. This goes with page 446. Okay. Some of these you're not graphing, some of them you are graphing. So on one piece of graph paper, here's a piece of graph paper, here's a piece of graph paper, and here's a piece of graph paper. You need to number them just as I have them numbered up here because you're not graphing all of them. Okay, the ones you have to graph I already noted up here. So 1, 2, 5, 6, 7, 8 for the first page. Second page, 13, 14, 15, 16, 21, 22. Doug, what are you doing? Yeah, there are only 2 on each page. I lied. Okay, let's try this again. Thanks, Doug. I was thinking I was giving you guys the graph paper that I have 3 on. Okay, try this again. The first one, just do 1, 2, 5, 6. On the back, so on the second one, 7, 8, 13, 14. On the third one, 15, 16, 21, 22. Yeah, it does. And then on the last one, 23, 24, 25, 26. Zach. Adam. Just 2, Adam. Don't hog the graph paper, Adam. Okay, so, Donatus. Mary or Jeremy, are you guys hogging graph paper? Jeremy, how many pieces do you have? 3. You should have 2. Okay, give one to Donatus, please. You're leaving Donatus out. I'm getting there. Hold on. Okay, so graph paper. Hopefully you guys all have it organized. You have 2 pages. Each side should have those numbers on. All right, now, a couple things I have to talk about. 1 and 2 tell you to make a mapping diagram. 1 and 2, you don't have to do that. You guys are good enough at looking at it and determining if it's a function or not. Justin, if you need to go to the restroom to get a Kleenex, go ahead. Okay, so that's the first thing. You don't have to make a mapping diagram. Okay, 18, 19, and 20, you're going to be confused. So I want everyone to look at the chalkboard. 18, 19, and 20 give you f of 0 equals 3, f of 4 equals 9. Does anyone know, Donatus, anyone else besides Donatus? 18, 19, and 20 give you something weird looking. Donatus, do you know what that means? Yeah? What does the 9 mean? Yep. Now, you do not have to know what Donatus just explained to us. Okay? The reason I'm giving you 18, 19, and 20 is it has you write an equation, and I want you to practice those. So for 18, 19, and 20, inside parentheses is 0. What it's equals to is y. So for all of these, each of them you are given 2 ordered pairs. And I'll leave this on the board. 18, 19, and 20, you're given 2 ordered pairs. You will have time, you should have time to get to that in class or at least start it. So ignore the F of what's in parentheses. You don't need that for the test. I will give you 2 ordered pairs. Okay, the book just did that a little bit differently. Yes, Annalise?
But then why does it say, like, why does it have the letters? Like,
Ignore that. Ignore it. Ignore it. I didn't teach that to you yet, so ignore that for now. Okay, also, the second part of your assignment is page 447, 1 to 13. That's an easy page. 447, 1 to 13. So I'm going to leave this up here. We have about 12 minutes. I wanted to have more, but that never happens. Up on the podium, for now I'm going to leave my answer keys. Okay, if you guys don't get to all of them by the end of class, I can post them on Blackboard. Okay, review's due Monday, test is Monday. Okay, so go ahead and get started. If you want to work with someone, you can. Matt? If you don't need to, then you don't have to. It tells you to represent it as a graph, but if you can do it without that, then go for it. Mary? Well, yeah, Mary, any number that you don't graph, you have to do on loose leaf. Okay.
1 second. No, I'm not. Miss Galliotis.
Yeah.